Hello, everybody. What we're going to be working on today is writing equations for sine and cosine functions. And when we look at these functions, you can tell we can either express the equation in terms of sine or cosine. We are going to do both. So let's get started. So the first thing that I think we should do is I think we should highlight which curve we're going to be using for sine and cosine. So what I like to do is I like to kind of look for the midline, okay, which we can see right here. And then for cosine, remember, or for sine, we go from the midline up, down, and back to middle. Okay. Now, I could have done any other function as long as I start in the middle, up, down, back to middle. I could have even started here, down, up, back to middle, here, down, whatever. It's just whatever you think. I usually try to find the function that's but the part of the curve that's closest to the y-axis as long as it's landing on nice points, which this one is. So for cosine, we remember that looks kind of like a curved V. So I look for, again, the one that's usually the closest to the y-axis, which looks like this one. Again, could you have done one starting here and it would have been upside down, or you could have even gone over here? Okay, so lots of options. So first thing we're going to do is find the amplitude. Now, you can simply count from the midline, 1, 2, 3, and that works. But another way is to take the highest point minus the lowest value, so the max minus the min, and divide that by 2. 2 plus 4 is 6, divided by 2 is 3. Well, if the amplitude is 3 for this is the same curve, the amplitude is also 3 here. Next, we're going to look for the vertical shift. So again, I've already found it. This one was easy to find. This is a nice graph. We can actually see that the vertical shift is at -1. But sometimes you're going to have graphs that are not labeled. So you might be able to see the high point and the low point, but you can't quite tell the middle or we don't label it. So for that, you're just going to average the two. So the maximum height is 2. The minimum height is -4, and we divide that by 2 because we're just taking the average. -2 divided by 2 is -1. And again, that will be the same for both of these. Okay, so let's take a look here. Now we have to figure out the period and calculate the b value. So if we look at sine, we can see that it starts here. Oops, I wanted a different color. It starts here at -pi/2 and it ends here at pi/2. So what we will do is we will take pi/2, the right endpoint, minus the left endpoint. Add those two together. So right minus left. Add those two together, we get a period of pi. Now that's not the b value because we need the b value to actually write the equation. Remember that? So what we're going to do is we're going to use the equation that says the period equals 2 pi over b, but we're going to switch that around a little bit. And we're going to say that b equals 2 pi over the period. Okay, because all I did was cross multiply and then solve for b. So b equals 2 pi over the period, which in this case is pi. And that means that our b value is 2. Now again, if the b value is 2 for this function, this is the same thing. So the b value is also 2. Next, we have to find our phase shift. This will be different for these two. We know that this function starts at -pi/2. So our phase shift is that it moved left pi/2 units. Okay. For this one, it moved to the left a little bit, and we have to figure out what that is. Well, that value is right smack between 0 and -pi/2, which means halfway between, it's moved left pi over 4 units. So now it's time to write our equations. So what you can see and what's really important is that there are a lot of things that are the same for these two. The one that is different is the phase shift because one has moved, left or right a different amount than the other. So let's do this. So for sine, we have f of x equals the amplitude, which is 3, times the sine of the b value. So our b value is 2. We have to think about our phase shift now. If it moved left pi over 2, we put x plus pi over 2. Okay, remember opposite. And then we look at the amplitude, it was moved down 1 unit. So that's the equation for the sine curve that we have here. In terms of cosine, it's going to look a lot the same. So it will be f of x equals, it's the same amplitude. Now be mindful, sometimes we're going to have one that's reflected, this one's not, times the cosine of the b value, which is 2. And here's where it's different. This sine curve is only moved over pi over 4 units to the left. So x plus pi over 4. And then, of course, the amplitude is the same because our midline is the same. So we have to move down 1 unit, our vertical shift. So those are two equations that represent this function. And of course, there were actually lots of different equations we could have written depending upon where we started our curve and ended our curve. Okay, but certain things will be the same. So looking at the equations, the amplitudes of the two are the same. The vertical shifts are the same. Whoops. The period or the b value, those are the same. So b value. Really, the only thing that was different was the phase shift. Okay, how far to the left or right did the functions go? They will never be the same. Okay, they'll never be the same. And just keep in mind something that sometimes one could be positive and one could be negative. So that could be different as well, depending upon what curve you choose in your initial step. So let's go ahead and let's look at the next one. Okay, I'm going to zoom in a little bit here because it's going to be way too small. And let's see what we can do here. So some values, again, are going to be the same. Some are going to be different. So first thing you want to do is for sine, you want to figure out where you'd like to start your curve. I can see here, okay, this is a height of 3. This is a height of -1. Right smack in the middle is 1. So it's a good idea to put that in there. And this is a good spot because look, it starts right on the y-axis. So that is our sine curve. So we'll do sine in red. And for cosine, again, we have to pick out, something that looks reasonable. We could perhaps go here. Okay, we could have started here and been upside down. I actually think I'm going to start here. And when we write our cosine curve, I'm going to use this one right here. So let's go through. Amplitude. Well, this is a high of 3, a low of -1. Okay, 3 minus -1 is 4 divided by 2. I'm sorry, 3 minus 1 is 2 divided by 2 is 1. And again, you could have just looked at this, right? The amplitude, I'm sorry, I was doing phase shift. All right, let's pretend that didn't happen. The amplitude is 2 units because it's 2 units above. Sorry about that. 2 units above our vertical shift, which is 1. Okay, sorry about that. Let's find our b value. So when we look at this one's pretty easy because we can see that we're starting here and we're ending right here, which is pi over 2. I'm looking at the sine curve, by the way. So we're going from 0 to pi over 2. So remember, what we're going to do for the b value is we'll take 2 pi divided by the period. And in this case, the period is pi over 2. As usual, we're not going to divide by a fraction. We're going to multiply by the reciprocal. So our b value is 4, which remember what that means is there will be 4 full curves in a period of 2 pi, the normal period. And the phase shift for sine is not, it's 0. Cosine is a different story. Okay, cosine did shift over. Cosine shifted over to here. So the phase shift here, it did move to the right. And now we have to figure out what this value is, right? Well, if this is pi over 2 and it's been divided into 4 spaces, pi over 2 divided into 4 spaces is pi over 8. Okay, so it moved to the right pi over 8 units. So let's write the equations. Remember, lots going to be the same here. So for sine, we have our amplitude of 2 times the sine of our b value, which is 4, times x, because we don't have a phase shift. And then we add 1, which is our vertical shift. For cosine, a lot of it's going to be the same, just what's happening inside these parentheses might be different or will be different. So f of x equals 2 times the cosine of 4. And now this one moved to the right, pi over 8 units. So we'll have x minus pi over 8. Remember, it's the opposite in there, plus 1. Okay, so when you figure out most of the values, they apply to both of them except for your phase shift. I'm going to do one more with you. Oops, why is it not moving? Here we go. Where am I? Okay, so let's try to do this again. There we go. Okay, so let's go ahead and let's do the next one. Okay, this is obviously a very stretched out curve like the accordion. So looking at this, we can see our midline very clearly is at 2. Okay, so we already know our vertical shift is 2. And we can very easily see that our amplitude is 1. Okay, no reason to do calculations for that. Now let's talk about sine, which I will do in red again. Sine goes from the center to the max, to the center to the min, to the center. So I'm going to start right here. And this is going to be the curve that I will write the equation for. And for cosine, remember, we're looking to either go from peak to peak, okay, or minimum to minimum. I'm going to go peak to peak. So I'm going to go from here to here. So that will be my cosine equation. Okay, we'll do that one in green again. So we have our vertical shift, we have our amplitude. So for our phase shift, okay, our phase shift, this moved to the left 3 pi over 2. So I'm going to put negative 3 pi over 2, meaning it moved to the left 3 pi over 2. And for our b value is 2 pi divided by the period. Let's see what this period is. It goes from 3 pi over 2, negative 3 pi over 2, to positive 3 pi over 2. So we have to ask ourselves, what's 3 pi over 2 minus negative 3 pi over 2? Remember, we do the right minus the left there. What we get is 6 pi over 2, which gives us a period of 3 pi. So remember, for the period, we do right minus left. So 2 pi divided by 3 pi, that's easy math, Get rid of those pi symbols, and we're left with a b value of 2/3. Okay, let's look at cosine. And the only thing we have to do for cosine now is the phase shift. So let's take a look. Well, what's right smack between negative pi and negative pi over 2? If you're unsure, you could average those, but hopefully you know that it's negative 3 pi over 4. And again, you could have added them and divided them by 2, and you would have gotten the value right in the middle. Okay, equation time. For sine, we're going to do f of x equals the amplitude, which is 1, so we don't even have to write that, times the sine of, we put our b value in now, 2/3, times x. Now, we had a phase shift of going to the left 3 pi over 2. So remember, we put plus 3 pi over 2 inside the parentheses. And our vertical shift, we moved up 2 units. Everything in the other equation will be the same except for what is going on in here inside our parentheses. So we have f of x equals the cosine of 2/3 of x. And now our phase shift was this. So we put plus 3 pi over 4 plus 2 on the outside of the parentheses. And we're all done. So here's what I'd like for you to do. I'd like for you to stop this video. And then I want you to go ahead and try numbers 3 and 4, and then start the video up, and I'll have the information done for you. Okay, so go ahead and stop this video. Okay, so how did you do? If you look at these, you may not have used the same curve as me. And so if you didn't use the same initial curve, the phase shift value would be different. Okay, so just be mindful of that. And everything else should be the same for sure. So on the first one, on this one, I chose this sine curve. Again, I like to try to stay close to the y-axis, which meant that it was going to be negative because it was going to the minimum, center to the minimum, center to the max, center. If you chose to start over here, your phase shift would have been different. Okay, I think it would have been 7 pi over 4, or 1 1/3 pi, or 1 3/4 pi, sorry. So just take a look at that. Hopefully you did okay. If not, really think about, what did I do wrong? Are you getting the b values wrong? Really think about the equation that we used to get the b values. Okay? Have a wonderful day.